So now we're going to do this class exercise that also will be provided on the problem set for this lecture. We're going to see different stocks that are interrelated on the system describing population dynamics on the Easter Island. I hope you're familiar with Easter Island. Easter Island is the most dramatic claim to fame. The most dramatic claim to fame is an array of almost 900 giant stones figures that date back many centuries ago. So this civilization was there for many years, but then the end of the civilization was not clear. The thing that is known is that all the trees in the island most of the trees were completely depleted, and it is believed that palm trees were used to construct homes and boats. And it is also believed that the resources that fueled the growth in the Easter Island population ran out. So this is by describing the system just briefly as the way that I described. This may be a typical case of an overshoot and collapse system, right? The behavior of an overshoot and collapse. This is the stock and flow diagram created from the information available on Easter Island, where we have two main stocks, which are population, status, and coconut palms. So analyze the model shown below for simulating the population dynamics on the Easter Island during the construction period of Easter Island status. The model contains simple relationships between the population and the source base as well as the status that were built on the island. So we now clearly identify some of the behaviors that we've been discussing in this session. One of the first behaviors that we started discussing was the linear growth or decay. So in this case, in the example of the Easter Island, immigration was seen as a constant value. So if you will need to provide information in your stock and flow diagram submitted to Stella, it will ask you here for a value, a specific value, not an equation. So this flow on its own, will lead to a linear growth or linear. Well, in this case, is a positive flow, which will be a linear growth. Of course, the final behavior of the population is not only dependent on the immigration, but it's also dependent on the birth and deaths, right? So the behavior might be different, and as I mentioned before, we can clearly see that it may lead to an overshoot and collapse. So a growth of the population and then a completely decrease on the population, reaching values to zero. But we want to analyze if we are able to see all the systems behavior that can be identified. So let's analyze the status. In the status, the flow of decaying is dependent on the stock. So, and also it depends on the decay fraction. That means that in this case, we have an exponential growth in this. We are able to identify an exponential growth. Constructing is also an independent in this. In this diagram is not independent. It depends on the population and it depends on the construction productivity. Other exponential growths that we can identify are here and are here, right? And then we can see, we can clearly identify here logistic growth. This equation on the logistic growth has been created in a different way as our previous stock and flow diagram for the logistic growth, where we also had a flow, another flow here. And this is because probably the equation of the growing that you will analyze later on the problem set has been constructed all together here. So it is already including the inflow and outflow of the equation of the logistic growth. But it includes all the components that we discussed for the logistic growth, which is the first constant value, which is the growth rate, the carrying capacity, and the stock, right? We also have interacting behaviors, which means that we will have, as I mentioned to you before, an overshoot and collapse, or any oscillating behavior, but it might be very unlikely if you look at the diagram. So it means that what we can see here is that the coconut palms have also the equation of the differential equation that is being created according to the flows in and out from the coconut palms include population. So include this stock. At the same time, the equation that can be created from all the inflows and outflows of population include the stock of coconut palms through harvesting per person. So harvesting per person is a converter, parameter that converts probably in the units from the stock of the coconut palms, from the units of the coconut palms to get into the system of population and to be consistent with the units on the population. All right?